हेलो माय डियर मैकेनिकल इंजीनियर्स, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? प्लीज गाइज डू जॉइन मी फास्ट फॉर दिस वंडरफुल MSQ's practice session for the fluid mechanics as well as the thermal engineering. So today we will be discussing some beautiful questions from fluid kinematics as well as first law of thermodynamics. So please do join me fast, and those who are already here, do respond me through the comment section if my audio and visual quality are fine. Can you guys hear me? Yes? So before I start, let me quickly introduce myself. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination which is conducted by UPSC. I have worked in Steel Authority of India Limited for a couple of years and also a private consulting firm for more than 2 years. So my total industry experience is more than 4 years, and the rest of my experience is completely into teaching. I have been guiding the students from last 10 plus years for various competitive examination like GATE, ESE and other PSUs. I am quite comfortable in these many subjects of mechanical engineering. Fluid mechanics is common for civil and mechanical. So please do join me fast, and those who are already here, it is my humble request to all of you, please respond through the comment section, mark your presence, mark your show your energy level so that we can start this MSQ practice session. Most of the students face difficulty in attempting the MSQs because more than one options are correct. So students do not develop the confidence in attempting the MSQs, and that is the reason I have brought this session for you, to make you understand, to make you comfortable with MSQs so that you can attempt these type of questions in your actual GATE 2024 examination. Hi Pradeep, good evening, welcome. So if you have anything to discuss, or if you want to connect with me, you can always write me a mail to my official mail ID, that is chandra.shekhar7@byju's.com, or it is always preferred that you join me on the Telegram. My Telegram channel is Mechanical by Chandrasekhar. The link is also given at the bottom, or you can scan the QR code to join me on the Telegram. Lot of students are already part of my Telegram channel who are appearing or who are preparing for GATE 2024 examination and other PSUs also. So you will definitely get benefited if you join such a group where all the students are like-minded, preparing for their competitive examination. Moreover, I will be giving you the exam notifications, the study notes and PDF will also be provided to you, the updates about the various sessions, and important questions and doubt resolution will also be done through the Telegram channel. All right, shall we start? So please keep your pen, notebook and calculator handy and try to solve as many questions as possible. Try to give me the answer for the questions through the comment section, and try to get all the answers, because there are more than one options to be correct in each and every question here. So please try to get all the correct answers as per your understanding. I will be there to help you out if you face any difficulty. All right, so BYJU'S exam prep is running mega mock test, all India level mega mock test for all the GATE 2024 aspirants. 2 subject-wise tests had already been over. The third subject-wise test will be starting from 11th of November till 17th of November. You just have to register yourself. The registration is completely free, and to register yourself, the link is already there in the description box. So once you attempt the mega mock test, test number 3, which is having the syllabus to be manufacturing, engineering mechanics, engineering materials, industrial engineering, as well as IC engine. So based on your performance in this test, you can unlock our test series for the discounted prices. Hi Maniket, welcome, good evening, what's up, how was your day? So the pattern of the examination will be as same as that of your actual GATE pattern. 65 questions, 100 marks, 180 minutes, 3 hours. Alright, and then there will be next subject wise test, and then there will be 4 complete full length test. Alright, so let us start. Please mark your presence, write something in the comment section if you are all ready. Write yes or no in the comment section so that we can start with question number 1. So first there will be some questions from the fluid mechanics, that is fluid kinematics, and then there will be some questions from the thermal engineering or first law of thermodynamics. Alright, so let us start with question number 1. Question number 1 is on your screen. Everyone read the statement very carefully, because there might be some confusion in some of the statements. If you will have the in-depth understanding of kinematics, and if you will read the options, understand the options carefully without committing any silly mistakes, then only you will get the right answer. Yes, you are supposed to choose the correct statements out of the following given 4 statements. Statement A says, a fluid flow is said to be irrotational when the fluid has 0 vorticity. Vorticity is twice of angular velocity, and if this is 0, or we can say that is called as del cross V. Vorticity is equal to del cross V or curl of V. Curl of V is equal to 0, then the flow is definitely irrotational. A is correct. Yes, well done Maniket, A is definitely correct. What about B? Psi is the stream function. Yes, the Laplace equation del square psi by del square psi is equal to 0. What is del square psi? That is equal to del square psi by del x square plus del square by psi by del y square is equal to 0. This is called as Laplace equation for psi. The Laplace equation is true when the flow is incompressible. Do you remember, do you know psi exists for all types of 2-dimensional incompressible flow? So existence of stream function guarantee the flow possibility. The flow is incompressible when psi exists. It do not have to satisfy the Laplace equation. It does not have to satisfy the Laplace equation. When psi satisfies Laplace equation, here people committed mistake. If psi satisfies all types means rotational plus irrotational. All types mean rotational plus irrotational. If psi satisfies Laplace equation, if the psi satisfies Laplace equation, then the flow is irrotational. Then the flow will be irrotational. Flow is always incompressible. For the flow to be incompressible, for the flow to be 2-dimensional incompressible, psi does not have to satisfy the Laplace equation. When the psi satisfies Laplace equation, the flow is irrotational. Do you agree with the statement B, which is incorrect? Do you guys agree with the statement B, which is incorrect? Statement C says stream lines and equipotential lines are orthogonal everywhere. Stream lines and equipotential lines are orthogonal everywhere. Do you remember? Except at stagnation point. What is stagnation point? The point of 0 velocity. The point where the velocity is 0, at that point the condition does not apply. So stream function, stream lines and equipotential lines are always orthogonal to each other in a flow field except at stagnation point. So there is some condition for this. Statement C is, that is the reason statement C is also incorrect. Velocity potential function exists only for irrotational flow. That is true. That is why potential flow is also called as, ideal flow. So only A and D. That is how you need to understand the each and every statement carefully. Hi Pankaj, Rohan, Rajput, welcome guys, welcome to the session. You are just little late, but better late than never. I welcome you all once again. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalam Walaikum, Wanakam. Please get yourself settled down fast, sit back, relax and enjoy the beauty of this session. And my humble request to all of you is, please do participate in the session. It will become more interesting, more fun, more lively, more energetic, right? And more fruitful. The next question, question number 2 on your screen. बी ऑप्शन में इनकंप्रेसिबल होने की बजाय इरोटेशनल होता तो करेक्ट होता. मनिकेत, ऑप्शन बी में इरोटेशनल होता तो करेक्ट आंसर होता. A fluid flow is represented by the given velocity field. Now what we need to check, it is a numerical, simple numerical. You need to check whether the rotational component omega z, angular velocity about z axis, is -1 unit. The rate of shear strain is 3 unit. Flow is incompressible, flow is irrotational. First of all, find out whether the flow is compressible or incompressible. Can we relate it with ui cap plus vj cap? So u is equal to x plus 2y minus 1 and v is equal to x minus y minus 1, isn't it? Yes. Question number 2, waiting for your response. Everybody, please give it a try. First of all, please check whether it is incompressible or compressible out of C and D option. Is option C correct or incorrect? How to check whether a flow is incompressible? What do we do? Two-dimensional incompressible flow. If we apply continuity equation, for two-dimensional incompressible flow, del u by del x plus del v by del y must be equal to 0. So what is our LHS? Del u by del x, that is 1, plus del v by del y, that is -1, is equal to 0, is equal to RHS. So definitely flow is incompressible. Yes, vlogs, Kalakal vlogs. Yes, so flow is incompressible. Check whether the flow is rotational or irrotational. Find out angular velocity about z axis. What is angular velocity about z axis? It is average of rate of change of angles of initially drawn perpendicular line segments, del v by del x minus del u by del y. So half of what is del v by del x, that is 1, minus del u by del y. What is del u by del y? That is 2. So how much is that? -1 by 2. 1 minus 2. It is -1 by 2. So it is neither irrotational nor the rotational component is -1, isn't it? So C is correct as of now. What about the rate of shear strain? Rate of shear strain or epsilon xy is equal to total rate of change of angles, del v by del x plus del u by del y. Here it will be plus and half will not be there. So what is del v by del x? That is 1 plus del u by del y, that is 2. So this will be 3 units. So the rotational or the rate of angular deformation or rate of shear strain is definitely 3 units. So B and C will be the right answer for this one, isn't it? B and C. Are you able to understand it? Option B and C are correct answers. Anybody is having any doubt, you just let me know through the comment section. Good, good, good. Rohan, Maniket, well done guys, keep it up. Yes, everybody please give the questions a try at least. Even if you are not able to get the correct answer, at least you will identify your mistake, your weak areas. That will help you to improve your understanding further. Strain का फॉर्मूला ये होता है, the total rate of change of the rate of shear strain या rate of angular deformation होता है the total rate of change of angles of initially drawn perpendicular line segments. If we want to write epsilon xy, then del v by del x plus del u by del y. If we want to write rate of angular deformation in yz plane, then we will write here del y plus here it will be del z. Here the velocity in z direction, that is del w, and the numerator of the second term will be the velocity in y direction. Similarly, epsilon zx will be equal to, here it will be del z, here it will be del x, so it will be del u here, del w here. So these are rate of angular deformation which we use in our Newton's law of viscosity. Rate of angular deformation or rate of shear strain or strain rate, or we can also call it as simply strain rate. Pankaj, clear? This is the parameter we use in our Newton's law of viscosity. Tau is equal to mu into d theta by dt. D theta by dt is rate of angular deformation. There is a slight difference between angular velocity and rate of angular deformation. Try to understand that difference. One difference is the angular velocity has negative sign in between and it is the average, so multiplied by half. So angular velocity will have half, then the negative sign in between the terms. That is the angular velocity. I hope it is clear. The next question is wonderful. Question number 3. Try to solve the next one. It will be little, it might be little time consuming. The question is about the acceleration of the particle at 1, y minus 1. X is equal to 1, y is equal to minus 1. We need to find out the acceleration for the given velocity. Can we write it as ui cap plus vj cap? So it is not a function of time. There is no time involved. So is D correct or incorrect? Option D. Find out the expression for u, find out the expression for v, and you need to find out the acceleration in x direction, acceleration in y direction, and the net acceleration. Everybody please give it a try. This is your question number 3. Let me give you a hint that option D is correct. Option D is definitely correct because velocity is not a function of time. So that is why local or temporal acceleration. Temporal acceleration means local acceleration. Local acceleration will be 0. Definitely temporal acceleration will be 0. D will be correct. Out of A, B and C. Out of A, B and C. So u is equal to this minus x square plus 3y and v is equal to 2xy. Now what is the acceleration in x direction? What is the formula? It is just formula based question. So ax u into del u by del x plus v into del u by del y. So what is u? Minus x square plus 3y into del u by del x. What is del u by del x? That is minus 2x. Then plus v, that is 2xy into del u by del y is 3. Put the value x is equal to 1, y is equal to minus 1. X is equal to 1, minus 1 plus y is equal to minus 1. X is equal to 1, that is minus 2, then plus minus 2 into 3. What will be the answer? 3 minus 1, 2 into minus 2, minus 4, minus 6, isn't it? सही लिखा है क्या मैंने? X is equal to 1, Y is equal to minus 1, Y is equal to minus 1. Tell me. Minus 2x minus x square plus 3y square. It is not 3y square. Sorry. It is not 3y square. It is 3y. It is 3y. So y is equal to minus 1. Y is equal to minus 1. So it will be minus. So it will become, sorry, it will become minus 4 into minus 2, 8. That will be 2 units. It will be 2 units. Option A is correct. What about acceleration in y direction? So AY will be equal to U into del V by del X plus V into del V by del Y. So put the value. What is U? Minus x square plus 3y. Del V by del X, that is 2y, plus V 2xy, then del V by del Y 2x. So x is equal to 1, y is equal to minus 1. Put the values. So AY is equal to x is equal to 1. So minus 1, minus 3, then 2y, that will be minus 2, plus 2xy, minus 2 into 2x, then 2. So it will be 8 minus 4, 4 units. AY will be 4. AY will be 4. B is also correct. What about C? What about C? The net acceleration is equal to under root of ax square plus ay square, that is under root of 2 square plus 4 square, that is root 20, that is 2 root 5. It will be 2 root 5. It will not be 4 root 5. It will be 2 root 5. So A, B and D are the correct options. A, B and D are correct answers. Yes, Maniket, well done. A, B and D will be the right answer for this one. A, B and D. I hope it is clear. Total acceleration is 2 root 5. 4.47, correct. It will not be 4 root 5. So option C is incorrect. A and B are correct and D is also correct. The next question is simple, but can you do the calculation correctly? Next question you are supposed to give me the answer for. Next question you guys are supposed to solve. So I will share the PDF of this session to my Telegram channel, guys. So if you have not joined me on the Telegram yet, please do join me. And do not forget to like and share this session as well to all your friends and colleagues, so that more and more people can watch the session, can get benefited. So the next question, you are asked to evaluate assorted fluid flow for their suitability in a given laboratory application. The following 3 flow choices, there are 4. There are 4 flow choices expressed in terms of 2-dimensional velocity field in x and y plane are made available. Which flow should be recommended when the application requires the flow to be incompressible and irrotational? Incompressible and irrotational. If we talk about A, what is del u by del x plus del v by del y? What is del u by del x? 0. What is del v by del y? 0 is equal to 0. It means incompressible. A is incompressible. What about irrotational? Del V by del X minus del U by del Y, isn't it? Can you find out del V by del X minus del U by del Y? What is del V by del X? That is minus 3 minus del U by del Y 2. That is not 0. It means rotational. So A cannot be the correct answer. A cannot be correct. Let us talk about B. What is del U by del X plus del V by del Y? Can you find out the value of del U by del X plus del V by del Y? Del U by del X. What is del U by del X? 2 minus 2xy plus what is del V by del Y? That is 2xy minus 2. So do you get it? 0. So B is also incompressible. And what about rotationality? Del V by del X minus del U by del Y. What is del V by del X? Del V by del X 2xy minus 3x square, then minus del U by del Y 3y square minus 2x square, del U by del Y na x square. So is it 0? It is not 0. It means it is also rotational. So A and B are incompressible but rotational. A and B are incompressible but rotational flow. Similarly, can you find out for C and D? If we talk about C, what is del U by del X? It is little time consuming though. Del U by del X is minus 2 plus what is del V by del Y? Then that is 2. So that is incompressible. And what is del V by del X minus del U by del Y? What is del V by del X? 0, 0. They are 0, 0. That is irrotational. So C is correct. What about D? Option D. Del U by del X plus del V by del Y. What is del U by del X? Minus 6 plus del V by del Y. That is 6. 0. Incompressible. All are incompressible. Then del V by del X minus del U by del Y. Do not commit the mistake. Del V by del X, that is 1 minus del U by del Y, that is 1. 1 minus 1, 0. That is irrotational. So C and D are incompressible as well as irrotational. C and D both are incompressible and irrotational. So answer to this question are C and D, isn't it? Answer to this question will be C and D. अगर कोई confusion, कोई doubt हो, तो you can raise your concern through the comment section. I hope it is clear to everyone. Are you guys enjoying it or not? So there can be numericals also for MSQs. There can be the theoretical question. Theoretical questions are more confusing compared to numericals, right? Let us move to the next one. The next question on your screen. Out of options A and B, one of them is correct, and out of C and D, one option is correct. Yes, in a Lagrangian system, the position of a fluid particle in the flow is described as, this is how the position changes in X direction and the position changes in Y direction by this expression, where T is the time while X0, Y0 and K are some random constants. The flow is option A and B. Which of them is correct? The flow is it steady or unsteady? Yes, I want everyone to get me the answer. A and B, which of them is correct? Forget about C and D. Let me know whether the flow is steady or unsteady. Do you know the definition of steady and unsteady flow? Will the flow be steady or unsteady? Every one of you. Will the flow be steady or unsteady? Yes, it is fun. The flow will be steady only. No, it means you guys do not have clarity in understanding of steady and unsteady flow. क्या होती है steady और unsteady flow की definition? How do you identify? सब लोगों को यह लगता है कि because x is a function of time, यही बोल रहे हैं आप. Similarly, because y is a function of time, इसकी वजह से अनस्टडी बोल रहे हैं सब लोग, इसकी वजह से इसको अनस्टडी फ्लो बोल रहे हैं. Let me tell you, whenever there is a flow, the position of the particle will definitely change with time. Whether the flow is steady or unsteady, the position of the particle, the position of the particle will always change with the time, whether the flow is steady or unsteady. वो तो होगा ही ना, टाइम के साथ पार्टिकल्स की पोजीशन तो चेंज होगी ना. तो इसका मतलब इट मींस यू आर ट्राइंग टू से देयर कैन नॉट बी ए स्टडी फ्लो इन रियलिटी. इज दैट व्हाट यू आर ट्राइंग टू से? क्या आप ये बोलना चाह रहे हैं कि स्टडी फ्लो डज नॉट एग्जिस्ट? स्टडी फ्लोज आर थियोरेटिकल. पोजीशन ऑफ द पार्टिकल तो टाइम के साथ एक जगह से दूसरी जगह पार्टिकल तो जाएगा ना फ्लो में, और जैसे जैसे टाइम चेंज होगा पार्टिकल्स की पोजीशन तो डेफिनेटली चेंज ही होगी. तो यहां से स्टडी और अनस्टडी फ्लो नहीं चेक करते. स्टडी और अनस्टडी चेक करते हैं वेदर द वेलोसिटी ऑफ द फ्लूइड is a function of time or not. Are you getting it? Velocity decide. If the velocity changes with time, then it is unsteady flow. If the velocity of the fluid particles do not change with time, then it is steady. Do you get it? Yes or no? Every one of you, do you guys get it? So how to find out the velocity in x direction? This is dx by dt. U is equal to dx by dt. Can you find out the value of dx by dt? Dx by dt differentiate with respect to time. X naught into minus k into e to the power minus kt, isn't it? And this x naught into e to the power minus kt is x only. X naught e to the power minus kt is x only. So u is equal to minus kx. Are you getting it? Similarly, v is equal to total derivative of y with time, dy by dt, and y is given by y naught e to the power minus kt, e to the power kt. So y naught into k e to the power kt. Are you getting it or not? Do you guys understand it or not? So y naught e to the power kt is again y. So v is equal to k into y. So it is neither be a function of time, it is also independent of time. U and v, can we say the velocity is a function of x and y only? So the flow is steady. Are you getting it or not? Yes or no? Are you guys getting it or not? So the flow will be steady, it will not be unsteady. x को चेक नहीं करते, x तो टाइम के साथ बदलेगा ही ना, पोजीशन तो चेंज होगी तभी तो फ्लो होगा, अदरवाइज तो स्टेशनरी. अगर इफ द पार्टिकल्स विल नॉट चेंज देयर पोजीशन विद टाइम, then it will not be a flow, it will be a static fluid, isn't it? It will be a static fluid. Now you need to check whether the flow is compressible or incompressible. कर सकते हैं. U is equal to minus kx, U is equal to minus kx, and V is equal to ky. So what is del u by del x plus del v by del y? Check the continuity equation for two-dimensional incompressible flow. Del u by del x is what? Del u by del x is minus k, plus what is del v by del y? That is k. That is 0. It will be incompressible. The flow will be steady and incompressible. B and D are the correct answer for this one. Good evening, MS. Good evening, everyone. Those who have joined me late. Once again, I welcome you all, guys. Do not forget to like the session and share it with all your friends so that more and more students can join live and get benefited. From today onwards, we will be starting a beautiful series for all the previous year questions GATE, but 90s previous year questions. Recent questions we have already discussed so many times. You may find on YouTube, different platforms, you can find the recent 5 years PYQs, 10 years PYQs, but we will be discussing the previous year questions, GATE questions from the 90s. All right, the series has already been started. Tomorrow and day after, I will be having 2 sessions, Fluid Mechanics Part 1 and Fluid Mechanics Part 2. So do not forget to join me tomorrow and day after tomorrow for these fluid mechanics, and today's strength of materials will be going on. All right, and there will be a scholarship test. पंकज, हम हर तरीके के सेशंस आपके लिए लेके आते हैं. मॉक टेस्ट भी हमने डिस्कस किए. टेस्ट सीरीज मॉक टेस्ट आर ऑलरेडी रनिंग. दे आर हैविंग द डिफिकल्टी लेवल सिमिलर टू द गेट पैटर्न. दे आर नॉट PYQs. You can appear for the mega mock test, and we also bring the practice sessions, but this time we have decided to discuss those questions which had been asked long back. Pattern does not change. There is nothing much change in paper pattern. To make your concepts clear, if your concepts are clear, it does not matter whether the questions are MCQs, MSQs or NATs. Are you getting it? If you are able to solve a numerical, the numerical can be framed as MSQ, it can be framed as NAT, it can be framed as MSQ also. So this time we are going to discuss, and your point is well noted. We will bring more practice sessions for your GATE examination, definitely. And there will be a scholarship test on 11th or 12th of November, that is Saturday and Sunday, right? From 9 AM to 9 PM. To join the session or to attempt this scholarship test, the link is already there in the description box. All right, अभी खत्म नहीं हुआ. हाँ पंकज, अभी सेशन खत्म नहीं हुआ. We will be moving further. Keep yourself charged up for the next round. आपको थोड़ा सा मैं ब्रेक दे रहा हूं, थक गए होंगे आप क्वेश्चन सॉल्व करते करते. एंड लेट अस मूव टू द नेक्स्ट पार्ट. ब्यूटीफुल वंडरफुल क्वेश्चन. ये क्वेश्चन कोई मुझे सॉल्व करके बता दे. देयर इज वेरी मच चांस ऑफ कमिटिंग मिस्टेक. द वेलोसिटी फील्ड विद इन ए लेमिनार बाउंड्री लेयर इज गिवन बाय दिस एक्सप्रेशन. दिस इज ui cap plus vj cap. Velocity profile is given. It is 2-dimensional flow where B is 100, the value of B is 100, and the free stream velocity is 0.1. So B into u infinity we can say 10. B multiplied by u infinity is 10. B multiplied by u infinity is 10. Right? The question says choose the correct option. The flow is incompressible. You need to check whether the flow is compressible or incompressible. The x direction component of acceleration at point x 0.5 y is equal to 50 mm. One is in meter, another is in mm, is -2 ax. Check whether ax is -2 or not. The slope of the streamline passing through the point x is equal to 0.5 and y is equal to 50 mm is 0.025. Let us first find out C and D option. Let us try to focus on C and D. What is the slope of streamline? The slope of streamline is dy by dx is equal to v by u, isn't it? Slope of streamline. Slope of streamline is dy by dx is equal to v by u. What is v? V is this expression. So can I write v as y square, because b into u infinity will get cancelled out. B into u infinity will get cancelled out. Let me write it as y square upon 4x to the power 5 by 2 multiplied by x to the power 3 by 2 upon y, isn't it? That is v by u. B into u infinity will get cancelled out. Now can you find out the slope at x is equal to 0.5 and y is equal to 50 mm. What is 50 mm? 0.05. So put the value. Can we write it is 1 by 4, and can we say y, it is simply y square upon y is y into x to the power, can I say 3 by 2 minus 5 by 2 minus 1, isn't it? 3 by 2 minus 5 by 2 minus 2 by 2 minus 1. So it will be y upon 4x. What is the value of y? What is the value of y? Y is 0.05. What is the value of x? 0.5. That is 0.05 by 2. 0.05 by 2. How much is that? Isn't it 0.025? 0.025. Yes, dy by dx. The slope of streamline is correct. 0.025. Are you getting it? The slope of streamline passing through the point 0.5 and 0.05 is 0.025. The slope of the potential line, streamlines and potential lines are orthogonal to each other. So can we say the slope of potential line dy by dx for potential line is equal to 1 upon 0.025, isn't it? And it will be minus 1 upon 0.025. So what is minus 1 upon 0.025? 40 minus 40. Are you getting it? Minus 40. C and D are correct. It will be minus 1. It will be minus 1, Rohan. So minus 40 will be the answer. So C and D are correct. What about A and B? Let us talk about A. What is del U by del X plus del V by del Y? What is del U by del X? Take B into U infinity outside. B into U infinity. What is del U by del X? It will be Y into x to the power minus 3 by 2. So it will be minus 3 by 2 into minus 3 by 2 minus 1 minus 5 by 2. Isn't it? Plus del V by del Y. Then 1 upon 4 x to the power 5 by 2 del V by del Y, that is 2y. This will be the expression. Are you getting it? So it will be minus 3 by 2 into y is equal to 0.05 upon x to the power 5 minus 5 by 2. What is x? 0.5 to the power 5 by 2 plus 2 into 0.05 upon 4 into x to the power, or we can write it as 1 by 2. 1 by 2 into 0.5 to the power 5 by 2. Are you getting incompressible or not? Are you getting it as incompressible or not? It is not 0. It is definitely not 0. So A is incorrect. What about B? Can you solve for B? Can you solve for B? So it is compressible. So C and D. What about option B? I am not going to solve for option B. Ax is equal to U into del U by del X plus V into del U by del Y. If you will do the calculation at X is equal to 0.5 meter and Y is equal to 0.05 meter, if you will not commit any mistake, then acceleration will come out to be. किसी ने solve किया? Did anyone solve it? Ax will come out to be minus 5 meter per second square. Definitely it will not be minus 2. So C and D are the correct answer for the given question. I hope it is clear. I am not solving Ax. Ax you do on your own. put the value of u, calculate del u by del x, put the value of v, calculate del u by del y, and finally put x is equal to 0.5 and y. हाँ लेंथी है पर पूछा जा सकता है. Only A, C, D options are not that lengthy. C and D are options are not that lengthy. A is also fine, but calculating the acceleration is a tedious task actually. Calculating the acceleration will be a tedious task. B wrong है. Yes, B wrong है. A और B wrong है, C और D correct है. Well done, good. Alright, आगे बढ़े. नाउ थोड़े सिंपल क्वेश्चंस लेके आते हैं. लेंथ भी हो गया थोड़ा सा. अगले क्वेश्चन का जवाब आप लोग देंगे. द नेक्स्ट क्वेश्चन, you are supposed to give me the answer for the next one. Quickly, you should be quick for theoretical question, quick and accurate. What about next one, everyone? Which of the following statements are correct? कौन कौन से करेक्ट हैं? पाथ लाइन कैन नॉट इंटरसेक्ट. विच ऑफ द फॉलोइंग स्टेटमेंट्स आर करेक्ट? पहले ये भी चेक कर लेना करेक्ट पूछा है कि इनकरेक्ट पूछा है. सारे के सारे ऑप्शंस एक साथ लिखिए. अनिकेत, कुमार, रोहन, all the options which you feel to be correct, write all the options in a single message. Path line cannot intersect each other. Path line can intersect each other. Path line can intersect each other. There is no problem in the path line. Path line can intersect. In case of turbulent flow, path lines intersect. Whenever the flow is turbulent, path lines intersect with each other. Streamlines and path lines are identical for steady flow. Yes, whenever the flow is steady, streamline, path line and streak lines become identical. B is true. B is true. A तो गलत है पंकज, A तो गलत है. A क्यों बोल रहे हैं? Path line can intersect. Path line can intersect. A is incorrect statement. Yes, streamline cannot intersect. Why? Because tangent is equal to velocity. Tangent to the streamline is equal to velocity. Tangent to the streamline is velocity, and when the streamline intersect, there will be two tangents. At the intersection point, there will be two tangents. So there will be two velocities. So which is impossible? So streamlines cannot intersect each other. That is correct. अच्छा, cannot को can पढ़ लिया था, यही तो गलती होती है. C is correct. What about D? The spacing of the streamlines remain constant. No, as the velocity increases, the spacing between the streamlines decreases, or if the velocity decreases, the spacing between the streamline increases for steady flow for Q to be constant. So spacing of the streamlines does not remain constant, it changes. Streamlines can converge, streamlines can diverge. Streamlines can converge, streamlines can diverge. Are you getting it? So option B and C are correct. Only option B and C. कितने लोगों ने सही जवाब दिया? किसी ने भी नहीं. किसी ने भी सही जवाब नहीं दिया. Right? B and C are correct answer. The spacing between the streamlines converge. In case of nozzle, area decreases. ये nozzle है. Nozzle में streamlines converge होती है. Diffuser में streamline diverge होती है. So the spacing between do not remain constant. हाँ पंकज, एक्चुअली MSQs की यही तो ब्यूटी है. अगला क्वेश्चन, आई वॉन्ट आंसर फॉर द अगला क्वेश्चन एवरीवन. अच्छा, आपने करेक्ट दिया था रोहना, मैं देख भी रहा था, पर आपने दो टुकड़ों में दिया ना, तो इसलिए मैं आपके दोनों ही स्टेटमेंट पढ़ नहीं पाया. आपने सी तो बोला, बी कहां पे बोला आपने? बी तो बोला ही नहीं आपने. बी का मैसेज मेरे पास आया नहीं आपका. चलो कोई नहीं, गुड गुड गुड. द नेक्स्ट वन, द नेक्स्ट क्वेश्चन. Quickly, get me the answer. Theoretical question. Theoretical questions are more dangerous. The question is about the incorrect statement. गलत मत पढ़ लेना. The question is about incorrect statement. It is not about correct. It is about incorrect. Eulerian concept. Eulerian concept is applied to a particular section. Eulerian concept in fluid kinematics is for particular single fluid particle. No, it is for a section. For a section, or we can call it as control volume. It is called as control volume approach. So, statement A is incorrect. So, the question is to find out the incorrect statement. The question is to find out the incorrect statement. Steady and uniform flow has no convective and no local acceleration. That is correct. Correct statement जो है उसको select नहीं करना है. You need to select the incorrect statement, isn't it? The Lagrangian concept is for a section. No, it is for a particle. It is for a particle. So that is why C is correct. Del V by del T is equal to 0 for a steady flow. Yes, that is called as local acceleration. Local acceleration is 0. That is correct. So that is why you cannot select the correct statement. You are supposed to select. Yes, Lagrangian approach is for a particle and Eulerian approach for a section. Alright. So A and C. Well done. So many students have given the correct answer. Maniket, आप क्या बोल रहे हैं? A and C are the correct answer for this one. A and C. Let us move to the next one. ये बताइए. The next question. Choose the correct statement out of the given options. You are supposed to choose the right statement. Give it a try, every one of you. At 7:30 p.m. app class for real flow numerical practice. At 7:30 p.m. there will be app class. We will have a class on BYJU'S app. Okay. So you can download the BYJU'S app through the link, bit.ly link, which is given in the description box. अभी मैं दिखाऊंगा आपको. You can download the BYJU'S app through the bit.ly link, which is given in the description box to attempt the real flow class, to attend the real flow class. For a uniform horizontal acceleration, it is from the rigid body motion. If the container is given a horizontal acceleration, if the container is given a horizontal acceleration in right hand side, acceleration, then the free surface will be like this. For a uniform horizontal acceleration of the tank, maximum pressure will be on the front side. It will be lesser. Pressure at A will be less than pressure at B. Pressure at B will be more. PB will be greater than PA. PB will be greater than PA. So A is incorrect. The maximum pressure will be on the rear surface. B is correct. क्या हो गया अखिलेश? Maximum pressure will be on the rear surface, right? Under free fall of the tank. When the container is having a free fall, pressure throughout the liquid is PATM. That is true. The pressure is neither be a function of X nor Y nor Z. It remains constant, that is PATM. The pressure will be PATM everywhere. Under the free fall, under free fall of the tank, pressure throughout the liquid is 0. No, it is not 0, it is atmospheric. So B and C are the correct answer for this one. B and C will be the right answer. Option B and C. B or C होगा ना? Gauge pressure will be 0. Gauge pressure will be 0. I hope it is clear. On 8th of November at 7:30 p.m. there will be a live interactive workshop taken by Joshi sir for GATE 2025 aspirants. He will be discussing how to secure the various ways, the various techniques to secure all India rank under 100 in your GATE 2025. The link is already there in the description box. Let us move to the next one. Now some questions from the first law of thermodynamics or the thermal engineering. Yes, ऑप्शन सी को एक्सप्लेन. देखिए, डेल पी बाई डेल एक्स होता है माइनस रो ए एक्स, डेल पी बाई डेल वाई होता है माइनस रो ए वाई, और डेल पी बाई डेल जेड होता है रो इंटू जी इफेक्टिव, वेयर जी इफेक्टिव कैन बी जी प्लस माइनस ए जेड. अगर फ्री फॉल है, इफ ए जेड इज इन द डायरेक्शन ऑफ जी, सो इन दैट केस जी इफेक्टिव विल बी इक्वल टू जी माइनस ए जेड. अगर फ्री फॉल है तो ये जी हो जाएगा. फ्री फॉल का मतलब है एक्सेलरेशन इन जेड डायरेक्शन इज जी, तो जी माइनस जी विल बी इक्वल टू जीरो. इफेक्टिव ग्रेविटी विल बी जीरो फॉर द फ्री फॉल इफेक्टिव ग्रेविटी, एंड ए एक्स इज जीरो, ए वाई इज जीरो. सो डेल पी बाई डेल एक्स इज इक्वल टू डेल पी बाई डेल वाई इज इक्वल टू डेल पी बाई डेल जेड. तीनों के तीनों जीरो हो जाएगा. इसका मतलब प्रेशर इज नाइदर बी ए फंक्शन ऑफ एक्स नॉर वाई नॉर जेड. प्रेशर ना तो एक्स पे डिपेंड करेगा, ना वाई पे, ना जेड पे. एक्स और वाई पे तो वैसे ही नहीं डिपेंड करता, पास्कल लॉ, बट जेड पे डिपेंड करता है हाइड्रोस्टैटिक लॉ. बट इफ द कंटेनर इज हैविंग ए फ्री फॉल, द प्रेशर विल बी पी एटीएम एवरीवेयर. एट द टॉप ऑल्सो द प्रेशर विल बी पी एटीएम, एट द फ्री सर्फेस पी एटीएम, एट द बॉटम ऑल्सो प्रेशर विल बी पी एटीएम. हाँ, वही जी इफेक्टिव ग्रेविटी जीरो हो जाती है लिफ्ट में, इफ द लिफ्ट इज हैविंग ए फ्री फॉल. इज दिस क्लियर टू एवरीवन? सो प्रेशर इज पीएटीएम एवरीवेयर इन द फ्लूइड. द नेक्स्ट वन, नेक्स्ट क्वेश्चन, द आइडियल गैस लॉ इज वैलिड फॉर. अगले क्वेश्चन का जवाब दीजिए. The ideal gas law is valid for low density, when the density of the gas is very low, and density is directly proportional to pressure, and density is inversely proportional to temperature. So at low pressure and high temperature, A and D, low temperature and high pressure, low pressure and high temperature, isn't it? Ideal gas equation is valid for low density of the gas, and low density is at low pressure and higher temperature. The next one, the next question, consider a piston cylinder device which contains an ideal gas. The gas undergoes two successive cooling processes by rejecting head to the surrounding. First, the gas is cooled at constant pressure. If I draw PV diagram, first the gas is cooling. First the gas is cooled at constant pressure. It is a constant pressure cooling. Volume is directly proportional to temperature, that is 1 to 2, until T2 becomes 3 by 4 T1. So what is T2 by T1? T2 by T1 is equal to 3 by 4. T1 is actually in multiply. T2 by T1 is 3 by 4. Then the piston is held stationary. What is the meaning of piston is held stationary? Volume remains constant. The gas is further cooled to temperature. There is a further cooling. Here pressure is directly proportional to temperature, 2 to 3 constant volume. And T3 by T1 is equal to 1 by 2, where all the temperature are Kelvin. The ratio of the final volume to the initial volume. The ratio of final volume to the initial volume, V3 by V1. Can we call V3 is equal to V2? So it is V2 by V1. Can we say V2 by V1 is equal to T2 by T1? And what is T2 by T1? That is 3 by 4. So isn't it 3 by 4 or 0.75? So out of option A and B, ये थोड़ा सा ढंग से क्वेश्चन फ्रेम नहीं हुआ. Option A and B are for V3 by V1 and option C and D are for work done. C and D are for work done. So B is the correct answer. B will be the right answer. What about work done? W2 to 3 is equal to 0 because it is a constant volume process. So W total is equal to W1 to 2. What is W to do? 1 to 2 pressure into volume, V1 minus V2, pressure into volume, or we can say P1 V1 minus P2 V2. P1 V1 is MRT1 minus MRT2. Can we write W is equal to MRT1 minus T2, or can we write M into R into T1, 1 minus T2 by T1. M is 1, R into T1, 1 minus what is T2 by T1? What is T2 by T1? T2 by T1 is 3 by 4. That is RT1 by 4. RT1 by 4. RT1 by 4. D is the correct answer. ठीक है? D will be the right answer. So try to solve these questions. They are assignment question. Try to solve. The next MSQ class will be on 10th, after 2 days. Tomorrow and day after tomorrow. Tomorrow and day after tomorrow there will be fluid mechanics session for the 90s PYQs. Tomorrow and day after tomorrow there will be questions from 90s PYQs. So I will be back for MSQ series for dynamics and second law of thermodynamics on 10th. Alright. So tomorrow at 9 p.m. This will be the session at tomorrow at 9 p.m. Right. And that is what I was telling you. In each and every session, description box, there is a bit.ly link. This is the bit.ly link. You can click on this link to download the BYJU'S app. Are you getting it? MS मैंने बताया ना, tomorrow and day after, ये मेरा YouTube का सेशन है 9 PM, old is gold series, and on 10th, that is Friday, 10th November, 6 PM, MSQ, 6 PM है क्या? Right? ठीक है? Telegram, MS, please do join me on the Telegram. I share all my session links to my Telegram channel. This is the link to join on the Telegram. Rajput, other properties. Fluid behavior does not change with time. Pressure, density and velocity तीनों. राजपूत तीनों, प्रेशर, डेंसिटी एंड वेलोसिटी. राइट? तो चलिए 7:30 बजे मिलते हैं. लेट अस मीट एट 7:30. लेट अस मीट एट 7:30 ऑन BYJU'S ऐप. मैंने बताया अगर आपने BYJU'S ऐप डाउनलोड नहीं किया है, सो डू डाउनलोड द BYJU'S ऐप यूजिंग द bit.ly लिंक. दिस इज द bit.ly लिंक, और यू विल फाइंड इन माई in the description box of this session. All right, so that is all from my side, guys. Thank you very much for joining in and your active participation. See you at 7:30 and tomorrow at 9 PM for the YouTube session. Thank you. Take care and Jai Hind.